So now we can begin with the session of cement and lime industry. And I will leave the floor to Mrs. Lucia Fucci. Thank you.
Thank you. Ladies and gentlemen, distinguished guest speakers, I'm thrilled to welcome you to this session on hydrogen's role in decarbonizing the cement and lime industry. My name is Lucia Fuselli, Sector Lead for Energy Efficiency and Decarbonization at the Green Climate Fund, and I will be moderating this session. Cement is the second most consumed material in the world after water, with no scalable substitutes today. With 6% of all man-made emissions, cement is the second largest emitting manufacturing sector after steel. In a global context where societal needs and urbanization are expected to increase cement demand by 45% by 2050. The good news is cement has also the second higher maximum potential in emissions intensity reduction in its primary production. With appropriate technology, cement and lime production emission can be reduced up to 95%. It is the sector that requires also less investments in absolute terms for its decarbonization. So only 783 billion US dollars are required to reach the IEA net zero scenario, compared with the 2.5 trillion for steel. However, today's cement and lime production meeting reduced or low emission intensity stands at almost zero, and the technology, capital, infrastructure, and policy enablers are lagging behind. Together with ammonia, cement and lime is currently the high emitting sector with the highest level of implementation and context in maturity. Hydrogen can serve the cement and lime sector in several ways. First, as a direct fuel, replacing coal and natural gas in cement production. Second, as a reducing agent in the raw material mix, reducing the need for clinker, which is a major contributor to emissions. And third, for production plants equipped with carbon capture and utilization. So challenges abound. The cement industry already operates under narrow profit margins, meaning any transition process must be highly cost efficient. On the other side, infrastructure for hydrogen production and transportation needs significant investment and particular attention to safety measures. Pilots do exist, but the hydrogen market is developing and not yet mature. Within these challenges, however, lie also opportunities. Hydrogen can be a game changer for climate action, enhancing energy security and creating jobs. Similarly, transforming the cement and lime industry isn't just about emission reductions. It's also about innovation, economic viability, and securing no one is left behind in the transition. Hydrogen does hold promise in decarbonizing this industry, and we'll explore this potential today. Thankfully, there are pioneers in the field from whom we can learn from, and some of them are with us today. So I'm honored to introduce Mr. Mohamed Shaibi, a career spanning around 45 years in the cement industry, and president at Ciments du Maroc, a prominent force in Morocco's cement industry and part of Heidelberg Material, a global giant in the industry, targeting 50% CO2 reduction in 2030. It is also my privilege to introduce Mr. Abdelileh Chouar, Head of Sustainability, Innovation, and CSR at Lafarge Holcim, global leader renowned with the construction material industry. Mr. Chouar has over 2 decades of extensive experience in cement industrial projects, and his expertise and leadership have played a pivotal role in fostering sustainable practices throughout the industry and catalyzing its positive transformation. And finally, allow me also to introduce Mr. Leopold Villeroy, Project Manager, Hydrogen and Green Gases at ENGIE Tractebel, and former Project Officer at AFD, in charge of projects in the energy and water sectors. Tractebel has assisted in 100 plus global hydrogen and 20 e-fuel projects to date, covering renewable energy, hydrogen production, and carbon capture. So this session will start with 3 presentations. I encourage the speakers each in his own turn to come to the other microphone and present. So 1 presentation for each of our panelists, followed by a few questions to gain further insight and debate. And we will wrap up around 5 minutes before the end, highlighting some key takeaways. We will start with Ciments du Maroc, and Mr. Shaibi, the floor is yours.
Eh? Ça va, vous m'entendez? Ça va. The first channel is not decarbonization, but it's explained in English what I have to tell you. You know, cement, as introduced, is a basic and fundamental material for human being all over the world. And in 2050, there will be 3 billion housing plant needed at this moment. So it is essential to continue because we didn't substitute any other materials to build easily housing and infrastructure for humankind development. The origin of the problematic CO2 in cement is in his chemical making. To make cement, you need lime, which comes from limestone. You need alumina, silica, and oxide, iron oxide coming from clay. And when you mix to mix this, you need energy to grind them, and you need fuel to preheat and to heat at a high level temperature, near 2000 degrees in the kiln. All this process at each stage develop CO2 emission, directly or indirectly, because the electricity to turn the machinery also is often produced with fossil energy in large amount. So first, the energy, electricity, and the fuels are very important in the cost, and it is a very big burden all over the centuries for cement. Cement makers focus on the reduction of this consumption of energy, and consequently, every step they do in reducing the energy needs, they reduce the emission of CO2. Through these curves, you can see the commitment of the industrial sector at a global level, worldwide. And there is a strong commitment to go to final 2050 a net zero CO2 in cement and concrete. That means it is net zero on the concrete which is used to build the houses. The big part of this reduction, half of this reduction will be 50% will be attained in 2030, reference with the year reference of 2090. If we take 90 here, that is 2020, but if you go back to 2090, it will be 50% at 2030. And then to achieve 2050, many efforts must be continuous. First of all, efficiency, as I said, then efficiency in concrete production, then saving in cement and benders, then saving in clinker production. Then the most important is carbon capture and utilization, store or reutilize. Then decarbonization of electricity, that means use renewable electricity, and CO2 sink recarbonation, because as you may know, when concrete is begin older, the CO2 is recuperated recarbonating the concrete. So that is the process, and it is a long way. This is at the level of the world. Next slide, please. Here I'm speaking about the Heidelberg Materials Strategic Roadmap. You know, at the left, the commitment on sustainability. It's not only CO2 and climate problem, but also it's safe and inclusive, circular resilience, and nature positive. And this is 4 pillars. I am now focusing on the low carbon products, net zero in 2050. But still, you can see on figure 2 on the right there, up right, you have the 1990. We go with the 750 thermic unit per ton of cement, and in 2030 we will cut almost by half to 400 thermic unit per ton, with using clinker incorporation reduced to 68%, process and the most important also started at a small level, but there is already 10 million tons CO2 captured by CCUS. The schedule, you can see it from 2024 to 2030. A lot of projects of CCU or CCS and CCUS in different countries. And we are confident in the group to reduce CO2 by 10 million tons cumulatively till 2030. CIMAR, Ciments du Maroc, is a part of this strategy. And we start by one original project, which is the carbon sequestration through algae. We take from the chimney the CO2 and it go through tubes where there are algae, selected algae. And we have already a pilot which can be visited on 1/2 hectare. And you have seen on this that the project Morocco project is program is scheduled to 2026 to be upscaled. You can put the other if you want, if you may. So we launched this project. We have also started for a long time in Laayoune with wind to generate electricity for our plant there. And nowadays, after our 6 turbine, we decided to enlarge all wind farms for our sustainable, all plants now uses with the long contract use wind electricity for all machinery for long-term contract. And we arrived at a rate of 80% of energy is derived from wind. I think not in this our company, but all I think it is the average level for all cement industry in Morocco. Then we have the photovoltaic parks, which are developing on the roof, and everywhere we have a site, we develop a photovoltaic. After that, we are reducing our consumption by installation of heat recovery systems since 2011, and we are ongoing with the same mechanism in Marrakesh plant. We are also ongoing discussion for first to use working on a project with the support of the German and Moroccan governments to use green hydrogen and mix it to CO2 in order to produce methanol as a fuel, can be transported to be used as a fuel in the motor cars and other engines. And we also working about project making synthetic fuels by taking hydrogen from renewable power for electrolysis combined with CO2. That's what I said. So I must go faster in order to leave time for other colleagues here to present their presentation. I finish with recommendation. We are doing all this voluntary action, but if we want to speed, if Morocco, if we want to speed these actions, there must be some regulation and some incentive for the actors, because if we produce a low carbon contents products, they must be encouraged and to encourage the competition of this field. There must be some incentive like a low taxation for those products, or take these existing taxes and moderate them regarding the amount of CO2 in the products, for example. Many things are can be developed if necessary, but we are I'm ready to answer on public questions later.
Thank you so much, Mr. Shaibi, for this opening presentation. So we saw how the international efforts are declined at local level. Now let's hear from another global champion in the cement industry, Lafarge Holcim. Mr. Chouard, the floor is yours.
Thank you. Hope you can hear me well.
Yep.
So let's start with the first slide. I will just highlight a little bit what Holcim is doing on decarbonization and a little bit of some applications here in Morocco. The first slide, the next one. Just to show you that we are also thinking a little bit wider than just the cement production. It's around also how the building and the construction sector shall think differently, because for us, it doesn't make too much sense to produce low carbon cement and then after putting that in houses that are poorly isolated and then using thousands of megawatts to heat them, or doesn't make sense to use so much cement when we can build differently, or having buildings that are more durable also on their lifespan. Doesn't make sense to build and to rebuild after 20 years and to rebuild after 20 years when we can have buildings that can last 50, 60 years. And the overall carbon footprint of that sector can be thought differently, and it's very true here in Morocco. So that's why we are working also not only on low carbon cement, but also on the globality of the construction sector. The next slide. Like Mr. Shaibi says, all the industry is working around the same topics. So the carbon footprint of cement is one on the left. If you just focus on scopes 1 and 2, there is a big chunk that is coming from the raw material, which is the decarbonation. And this is something we cannot avoid with producing clinker with the processes we have today. So it's almost 40% of our carbon footprint. We have also a big chunk coming from the fuels. So how can we reduce the carbon footprint? It's obvious we can use less clinker in the cement, especially that's what the aim of low carbon cement is using less clinker on the cement. The other one that we are working also here in Morocco is to reduce the fuel footprint by using other fuels, alternative fuels, especially the one, for instance, in Morocco that we try to use derived fuels from waste that can be an alternative to petcoke or fuel or classic fuel. And what remains last, and that is highly developed in Europe, because it's the last stand that we have when we have investigated low carbon cement, we have pushed everything to the boundaries in terms of alternative fuel, remains the carbon capture, which is the one that they are developing in Europe, which is a big stuff now. There's many projects that are funded by the European Fund to capture that cement and to put it on the ground so we can produce decarbonized clinker that can be used in cement. So this is the pathways that you see there on the right. Next slide. So what in Morocco, we are trying also to follow that path. We already signed via the Cement Association a partnership to produce fuel from waste, municipal waste, which is something that is a very ambitious plan for Morocco. We are also launching low carbon cement. So it's cements that have 30% or more. Can you come back? I don't know who is moving the slides. I don't have the
Can you
button,
get back
so
to the
it's not
previous
me.
slides, please?
It was just
Okay, that we
slide
have to
before.
cut, but we are being too quick now.
I can move it. This works? No, I don't think. Okay. The slide before, this one. And so we are moving on low carbon cement. It's important to note that these cements are a common thing in Europe for the last couple of years because it's a norm that has been launched in 2021. And in Morocco, we are still waiting for the Moroccan norm and the standards that will allow us to launch low carbon cements more heavily, especially something that could look like the LC3 that has been developed by EPFL in Switzerland that has a very low carbon footprint, 40% less than a normal cement. But we launched already in Morocco a few cements that are based on alternatives to clinker that have a footprint 30% or more less than normal cement. The next one. So Holcim has also engaged in huge decarbonation programs. So it's important to note that we have 6 projects that for Holcim that have received funds from the European Union. We have 2 main ones. I show you just the one in Lagerdorf here, but there is also another one that is as big in Belgium. It's projects that have quite huge scale because they are talking about 700,000 tons of CO2 capture every year. It's capex that are hundreds of millions of euros. Holcim has engaged from now till 2030 a program around $2 billion of investment in carbon capture. It's a public commitment that Holcim took. And the European funding is around $3.8 billion to decarbonize the industry by the end of 2030. And I'll show you just all the projects in Europe are looking like this one. They are by the fund. It's capturing the CO2 from the cement plants. And along with other industries in Lagerdorf, it's another industry that is partnering with it. Build an electrolyzer, mix the CO2 captured from the cement plants with the hydrogen produced by the electrolyzer, produce methanol, and find an off-taker. Here it's the Hamburg airport that is in Germany that will take all this fuel and use it to fuel the planes in Germany. So this will be a complete circular project, which is a big one that is called, I'm not German, so West Coast 100. And it's one of the flagship of Holcim projects in the future, along with the one for Mobourg and 4 other projects that have been funded that will materialize in Europe by 2030. Now I finished my presentation. Thank you.
Thank you, Mr. Chouard. So it is clear that decarbonizing cement and lime production entails not one, but a series of interventions on both product components and processes in a circular economy perspective, ideally. So let's then have a deep dive on technologies and ongoing pilots. Mr. Villeroy from Tractebel, the floor is yours.
Thanks a lot, Lucia. Good afternoon, everyone. So I'm Léopold Villeroy, project manager on H2 and e-fuel projects at Tractebel NG. Next slides, please. So a little disclaimer, this first slide and the next one. Okay. So those slides were presented around 2 hours ago on this exact same spot by my colleague Sven, who is here. So it's a good opportunity for those who were not here or those who were sleeping to catch up on Tractebel's activities. But if you want me to speed up because you were not sleeping, just make me a sign and I'll go quickly on this. Okay,
Let's go ahead.
so I had some signs, so I go quickly. Why am I here today with our colleagues from Simon du Maroc and Lafarge Holcim? And I'm not a cement industrial. Why am I here? It's because we, as Tractebel, an engineering company, we help our clients, like industrials, finding some technical solutions to decarbonize their activities. And therefore, we capitalize on our experience and expertise on hydrogen, on e-fuel, but also a lot of other crucial disciplines that are involved in the process to really find the good solutions to decarbonize the activities, depending on the sector, depending also on the environment, etc. Our role is really to do the studies, to help the clients, and then to supervise up to the completion of the projects. And I will just insist on industrial safety because this is one of the really crucial points and where we can really help our clients in those processes that are quite problematic. As a representative of an engineering company, I wanted to first explain the basics of e-fuel production process. So by e-fuel, we mean different e-molecules that can be used for different usage, either in mobility or industry. The most common are those, the e-methane, e-diesel, e-kerosene, e-gasoline, and e-methanol. They are all produced, let's say, through the same process with some small differences between them. The process is shown here on a quite high level view. First, you have the CO2 capture. So different sources can be cement industry with different technologies that have to be adapted with respect to the concentration of CO2 in the stream. You have H2 production with also different byproducts that are produced, such as oxygen and heat. You mix both the CO2 and the H2 through a step of conversion and a step of product upgrading. Those ones that depend on the final product that you want. And then you just have to find an off-taker. As an illustration, I would like to share you the experience that we gain through a project which is not a cement production project, but lime production project, to change a little bit. And as you know, lime is involved in the cement production. It's the project Columbus in Belgium, which is led by our mother company, ENGIE, and Carmeuse, a lime production company. It's located next to Charleroi. Nice city. The project is involving CO2 capture from the lime production process, H2 production, and methanation. So to produce up to 370 gigawatt per year of e-methane. The COD, so the commercial operation date, is foreseen in 3 years, in 2026, and it will help save up to 160 kiloton of CO2 per year. Tractebel in this project, as I said, our role is really to help our clients to define the project through the different steps. So pre-feasibility study, feasibility study, also helping on the permitting and technical safety, and smart feed. So what is a smart feed? It comes from our experience from both the thermal sector and the oil and gas, and to converge into, let's say, the best adapted approach, not to do too heavy engineering studies upfront, so to kind of reduce costs, but the right amount to enable both the permitting and the consultation of EPC companies to perform the work afterwards. And based on those smart feed studies, we are now entering into the tendering phase to select the EPC company that will do the construction. Here, my last slide is an illustration of the project, just to give you something visual, where you can see the kiln production, also the electrolyzer production, the CO2 capture, and the methanation plants. Thanks a lot for your attention.
So thank you, Mr. Villeroy, for your presentation. So we have got a high-level international, local, and technology perspective. So let's hear now some further insight from our speakers. Mr. Chouard, where are we in Morocco for low-carbon cements development? What are the key challenges faced by the cement and lime industry in reducing CO2 emission, and how can Power-to-X solution contribute?
I think one of the first thing is that the norms and the local legislations shall be adapted to follow the European. Europe is moving fast, Morocco is not moving fast enough. And so there is a lot of cements that we cannot, things that we cannot do that probably could be fast. And for instance, the low carbon cement norm has been in the pipe since July 2022, and it's not yet approved, so it takes a lot of time. The other Power-to-X solutions could be developed in Morocco. I believe strongly that Morocco can be a partner for Europe in developing a lot of Power-to-X solutions, because we have a lot of advantages, the wind, the solar power, etc. We can build locally green hydrogen plants, but we need probably some support, some kind of support, like the fundings that they have in Europe, to materialize these projects if they benefit Europe at a point in time. And we need also technology providers to work a little bit faster, so they can propose us some solutions that are competitive and that makes our business case better and cheaper.
And what kind of supportive policies and incentives can facilitate the integration of Power-to-X in the cement and lime industry, in your opinion?
Well, we have to think about it, but probably if we engage massive investments on this kind of things here in Morocco, there would be probably the need from the high-level perspective of the government to incentivize, to help, to support in a kind of way to facilitate those investments, because they, at the end of the day, they will create a lot of employments for Moroccans. So I believe strongly that we need a strong support government on this, not only speeches, things also that land on the ground.
Thank you, Mr. Chouard. Mr. Villeroy, solutions are still in their infancy and the related market have to mature, but can you mention any further successful case studies or pilot project for the application of Power-to-X in the cement and lime?
Yes, thanks a lot. My colleagues have both shown some interesting projects, with one of them being under construction. I can also cite some more projects that are developed by ENGIE, where Tractebel is acting as the engineering company. We work with several cement industrial on different e-molecules to be produced, so mostly in Europe, but we could also have really interesting case studies here in Morocco.
So thank you. Thank you, Mr. Villeroy. So finally, let's reconnect again with the global picture. Mr. Shaibi, we are witnessing an international effort towards establishing common principles, common standards, both in the hydrogen space and soon probably also in the heavy emitting sector ambit. And in parallel, there is an entire new global economy developing around green products and also around hydrogen. So how is Morocco interfacing with this new reality in terms of trade and in terms of dialogue?
Not an easy question, but I will proceed by declaring some facts. And through those facts, you will see, for example, November 22, the King chairs a working meeting on renewable energy and asks the sector's stakeholder to develop as soon as possible an operational and incentive Morocco offer covering the entire value chain of the green hydrogen sector in Morocco. Then July 2023, during the throne speech, the King called for a collective mobilization of public and private actors to ensure the success of this strategic project for the future of the kingdom. September this month, the head of government shared a ministerial meeting dedicated to operationalization of Morocco's offer in the field of green hydrogen. Major local players have shown the way, and I quote in particular the OCP, which has declared its intention to invest $7 billion for the dollar for the construction of its ammonia plant from green hydrogen in Tarfaya. The Mohammed VI Polytechnic University is also signing numerous partnerships of research and development with major end users and partners of this new source of green energy. In Germany, Berlin has integrated Morocco as a priority destination of H2UP PPP program, active in hydrogen projects in developing and emerging countries through one-site cooperation. May 4, CWP Global signed an agreement with the German group Hydrogenius, which specializes in the transport of liquid organic hydrogen, to carry out a feasibility study that will explore a transport chain of 500 tons of H2 per day from Morocco to Europe. Netherlands MOU agreed between the government that covers an overall budget of 305 million. Objective is to identify and develop together a public infrastructure in project priority sector, first and foremost renewable energy. In other words, everything is still possible, and in the cost consideration that will make the difference. It is the cost considerations that will make the difference. Morocco is seizing the present moment with all his strengths, establishing a legal and incentive framework decided on green hydrogen with the diversification of its partner, who will see that the renewable energy strategy is being fruit and makes it possible to complete the green hydrogen value chain.
Very impressive. Thank you so much. And well, transitioning towards a decarbonized future will also require new competencies and skills, and it will inevitably also imply that some of the knowledge connected with older technologies in the long term will become obsolete. How is the industry preparing, I mean, in Morocco, but ideally also internationally, for this shift to turn it into an opportunity and ensuring no one is left behind? What is needed on that front?
Hard question, exactly, because the human issue is always the hardest one to address. Mechanics and technology is easier, but the human is the essential. This morning in the planetary, one of our past minister of energy, Dries Ben Yema, said the renewable don't create jobs. This assertion, as simplified like this, seems true. But think about the old system. I mean the ecosystem. If Morocco build all the ecosystems, then there will be jobs. And then you in other fields, not the job we know, but the new jobs. That's, if I can read some suggestion, the transition will be much smoother if we rely on two fundamental aspects. First one, upskilling, offering the chance to upskill or refresh existing knowledge has a hugely beneficial effect company-wide. It boosts staff confidence and communication between teams and departments, and it allows us as an employer to create the workforce we need by investing in and developing the people who already know our business well. A decarbonized future should be demystified, explained, and associated with the new reality of decarbonized economy and revenue. It's a new approach that should be embraced by every layer of management. Upskilling is in the rigorous manner to align everyone in the corporation at a level of considering the shift and adapting the new model of their own tasks. Second, digital smart manufacturing approaches can optimize energy and resource use, improve supply chain management, and help the monitoring and use of energy at every production level. With the Factory 4.0 principle, employees and suppliers both are implicated in ensuring the new industry standards are met. We believe that digital matches perfectly with emission standards and energy optimization. Innovation clusters, research universities, and the private sector should create labs and hubs for innovation and best practices. Each industry has its own parameters, and only the R&D clusters can scale up the cost of innovation regarding green hydrogen and local specification. Upskilling and digital presents the right combo for a better corporative transition toward decarbonized revenue. I already remind this reflection of one I forgot the name. When innovation is going up, mankind are always afraid because fundamentally we don't like change. And if you look at the change not as a threat but as an opportunity, and then you transform old jobs with new jobs.
Thank you so much, Mr. Shaibi, and it's a wrap up for this session. We have learned that Morocco is definitely on the map and open for business and at the forefront when it comes to integration of Power-to-X on the cement and lime industry. At the same time, policies, regulations aligned with the West and local and international finance and incentives, as well as tech providers, are needed for the decarbonization effort to scale up and to ensure that no one is left behind in the ecosystem, but this shift becomes an opportunity for upskilling and innovation. To conclude, I just wanted to thank the organizers of the Power-to-X Summit and to solicit an applause for our distinguished speakers. Thank you for your time and insight. And thank you. And thank you everybody for having taken the time to attend this session. Wish you a great afternoon and evening. Thank you.